Welcome back to this introductory video series on Bio-Rad's BR.io cloud software platform for laboratory instruments. In this video, we will show you how to set up a run for the CFX Opus real-time PCR system in the BR.io cloud platform. To set up a run for the CFX Opus system, we must first navigate to the Create page by clicking on the link in the main navigation panel. Click the CFX Real-Time PCR link to open the Define CFX Experiment workflow. There are three main steps in the workflow: selecting a protocol, defining the plate contents, and entering run details. There is a workflow navigator at the bottom of the screen that can be used to move between the steps. The current step is indicated in bold. First, select the protocol that you will use for the run from the drop-down menu at the top of the page. This menu displays all of the protocols contained in your protocol manager. We will select the protocol that we created in the last video. Once a protocol is selected, it is displayed below. Note that you cannot edit the protocol when creating a run. Protocols must be edited through the Manage CFX Protocols page. Once you have selected the protocol for the run, click the green button that says Continue to Plate Setup. Now we need to define the plate for the run. This step is divided into two sub-steps. The first is selecting the plate details, which we will do using the settings on the right side of the page, and the second is defining the contents of the plate. Now let's select a scan mode for the run. The scan mode determines which channels are used to collect fluorescent data. If you are performing a Cyber green-based experiment, then change the scan mode to Cyber FAM only. This instructs the instrument to only collect data in channel 1 and decreases the duration of the run. If you are setting up a multiplex qPCR experiment or using probes with fluorophores other than FAM, then you need to keep this set to all channels. We'll leave it on all channels. After setting the scan mode, set the plate size and the plate type for the run. Once you have set the plate details, click Next Step to proceed. Now we can select wells and edit the contents of the plate. A default plate is provided that contains an unknown sample and fluorophore for each channel in each well. This default plate may be used to create a run quickly, and you can return and edit the plate layout during or after the run. If you do this, ensure that the plate details in the previous step are set correctly. Before we start editing the contents of the wells, let's look at how the well contents are displayed on the plate. Each well has two types of tags: sample tags and target tags. The sample tag has a rectangular shape and is displayed at the top of the well. The sample tag conveys information about the sample or DNA that is being tested in the well. This information includes the sample type, such as an unknown sample or a control sample, and the sample name, if defined. Target tags are displayed below the sample tag and have rounded corners. Target tags display information about the targets or DNA sequences being detected in the well. A separate target tag is present for each target or fluorophore that will be detected in the well. The target tag displays the target name, if defined, or the fluorophore when the target name is undefined. Now let's create a simple plate layout with 5 unknown samples tested in triplicate for 2 targets. We'll also include a positive control and a no template control. First, we'll clear the plate by clicking the button in the upper left corner of the plate, then clicking the Clear button. Now we will select wells and edit the contents. You can click on a well or click and drag to select multiple wells. You can also click on the column, row, or plate header to select wells. Holding the Control key, or the Command key on a Mac, will let you add or remove wells from the selection. When wells are selected, the Well Editor tools appear to the right. We'll use these fields to define the contents of the wells. First, let's define the targets on the plate. We'll select a block of wells that will be used for the first target, then set the fluorophore and target name. We'll use Cyber as the fluorophore and name the target as Target 1. If we were setting up a multiplex experiment, we could add multiple targets to the well by selecting additional fluorophores here. We'll repeat this step for the second target and name it Target 2. Note that when editing the target name, you can also use this drop-down menu to select any target previously added to the plate. Now, let's define the samples, starting by selecting the wells that will contain the first sample. Since this is a sample that we are testing, we'll leave the sample type set to unknown. We'll enter sample 1 for the sample name. We can also optionally define a biological group for this sample. The biological group is used to denote the experimental grouping for the samples, such as whether the sample belongs to a treated or control group. We'll label the biological group for this sample as treated. Let's repeat this process to add 4 more unknown samples to the plate. We'll label the biological group for the last 2 samples as control. After labeling the unknown samples, we will add the 2 controls, a positive control labeled reference and a no template control labeled buffer. The last step will be to label our replicate groups for the run. Each well that contains identical content is part of a replicate set, and each replicate set is defined with a number. Select all wells that contain identical content and enter a replicate number. We'll start with replicate 1 and count up as we label the replicate sets. Once the plate is defined, click the Continue to Run button. Now we will define the details for the run. First, we can change the run name if desired. It is pre-populated with a unique, automatically generated name for your convenience. Next, we can enter an optional plate ID. This field would normally be used for a plate barcode, which can also be entered at the instrument. Last, we can also optionally enter notes about the run. Since these 2 fields are optional, I'm going to leave them blank. When we are finished, click Save Run. This saves the run, exiting the workflow and returning us to the Files page. Our newly created run is listed at the top of the file list and can now be executed on a linked CFX Opus system. Note that the file type is currently CFX Run pending, meaning that the run has been created but not yet started on the instrument. It is represented by this icon containing the letters CFX and a blue play button. The file type and icon will change when the run is started on the instrument. Now let's go start the run. Okay, now we're at the instrument and we will use the touchscreen to start the run. If you haven't already linked your CFX Opus system to your account, there's an earlier video in the series that will teach you how to do so. To start the run, we first need to log into the instrument under our user account. Next, we'll click Files to access the file browser. Click br.io in the panel on the left, and then find your run in the file list. Only pending runs that are compatible with the instrument model will be displayed. Click on the Run file, then click Next. Make sure that your plate is loaded into the instrument, then click Run. The run will start. Now let's return to the br.io cloud platform where we can monitor the time remaining for the run. First, we'll return to the Files page where we can see that the file type for the run has changed to CFX Run in Progress. And the icon is a purple clock, indicating that the run is in progress. After the run completes and the data have been received by the br.io cloud platform, the file type will display as CFX Run Completed, and the icon will contain a green check mark to represent that it has been completed. Now we will go to the Instruments page. Here we see that the status for this instrument has changed to Running, and the time remaining for the run is displayed to the right. If we expand the instrument row, we see this yellow box with information about the run, the current cycle and current step, and you can also click the Go To Run link to open the run. Continue on to the next video in the series to learn how to review and export data from this run once it has completed. Thank you for watching.